Which of the following is the ground state electron configuration of a sulfur atom? A. 1s2, 2s2, 2p6, 2d6. B. 1s2, 2s2, 2p6, 3s2, 3p4. C. 1s2, 2s2, 2p7, 3s1, 3p3. Or D. 1s2, 2s2, 2p6, 3s2, 3p6. To construct the ground state electron configuration of an atom, we do the following. First, we determine the number of electrons. Then, we assign electrons to subshells following the off-bow principle. We fill the lowest energy subshells first. The best way to do this is to refer to the periodic table. Here's sulfur. We can see that it has an atomic number of 16. A sulfur atom has 16 electrons. Let's assign these electrons. The first subshell is the 1s subshell. We can put a maximum of 2 electrons in an s subshell. The next subshell is the 2s subshell. The next 2 electrons are assigned to the 2s subshell. The next subshell is the 2p subshell. Since a p subshell can accommodate a maximum of 6 electrons, we assign the next 6 electrons to the 2p subshell. The next subshell is the 3s subshell. We assign the next 2 electrons to this subshell. So far, we have assigned 12 electrons. We have 4 more to assign. These 4 will go into the next subshell, the 3p subshell. Therefore, the ground state configuration of a sulfur atom is 1s2, 2s2, 2p6, 3s2, 3p4. And the correct answer is B. Note that choices A and C should immediately stand out as wrong. In choice A, 6 electrons are assigned to a 2d subshell. There is no 2d subshell. In choice C, 7 electrons are assigned to a 2p subshell. That exceeds the maximum allowed, which is 6. Recall that Pauli's principle says that the maximum number of electrons that can be assigned per orbital is 2. For a p subshell, there are 3 orbitals. 3 times 2 is 6. Finally, choice D is also wrong because the total number of electrons shown is 18, whereas a sulfur atom only has 16 electrons.